All right. So how do you get a recursive backtracking algorithm? Right? You think, right? What you have to focus on. What are your instances? What are your solutions? What are the costs of your solutions given an instance? What do you ask the bird? What questions? What answers might you give? This is, in fact, exactly what I told you at the beginning of the, right? So in some ways, it's not really new here, right? So what answers does the bird give? And for each, you say what subinstance you give to your friend, what solutions does your friend give, right? How do you produce a solution for your instance from your bird's answer and from your friend's answer, right? And how do you get your costs? And then you take the best of the best, right? Everybody kind of get that? How do you get the dynamic programming algorithm? Is you think about running your recursive program on given your particular input, right? You don't think about inputs that you've never seen before, but your particular input, you run the recursive you think about running the recursive backtracking algorithm, and you determine what all your subinstances will be. You form them into a table, and you fill them out in order that nobody waits, right? And what we haven't talked about here is we don't actually fill in the solution because it's too big, right? Right. So why are we doing this bird thing? Because I feel it abstracts out some of the hardest parts of the problem, and it helps you focus on what you want to try. And because when you temporarily trust the bird, it lets you sort of dive into what your solution consistent with that bird answer is, right? And coming up with this bird friend algorithm is the hard part, right? Right. So you want to ask her about some property of the solution, and there's only so many questions you can ask, right? You can ask what's the last node, what's the middle node, right? There's only so many questions you can ask, right? So here, this is copied from my old slides too. I'm going to just list some of the types of bird answers you might ask, right? If my solution is a path, then I could ask the bird about the first edge, right? But we tend to flip it around, so we really ask her about the last edge, right? And then what do I ask my friend is for the rest of the solution, right? Right, and one advantage of this question is it has a good follow-up question for your friend to ask, right? Your friend will ask his bird, what's the second last edge, right? You only can ask her a little question, and by little we mean there shouldn't be that many algorithms, that many answers that she gives, right? Here, if I ask what's the last edge, then the number of answers corresponds to the degree of that node, right? But if I ask her what's the optimal solution, then there's an exponential number of answers, right? And so that's bad, right? If I ask her how many edges are in my optimal path, that seems like a good question, right? But it's not really a local question, it's sort of a global question. And it doesn't really have a good, how does it help us to solve the problem knowing the number of edges? And it doesn't really have a good follow-up question for our friend, right? All right, so suppose my instance is a sequence of objects, right? Oh, my solution is a sequence of objects, right? Then I could ask the bird, right, what's the last object in the sequence, right? And the number of answers is the number of possible last objects, right? And I could ask my friend something that will give me the rest of the solution, right? If my instance is a sequence of objects, that's my input, and my output is a subsequence, right? Then what do I ask her? Right, I could ask her, what is the last object in the sequence, right? How many answers are there? Well, they're in answers, right? I mean, this could be the last, or this could be the last, or this could be the last, right? Right, so they're in possible answers. What would be a better question where she has fewer answers? Think about short edges instead of long edges, right? This is kind of a long edge. What would a short edge be? Just think about A. Tell me something about A. Do we take it? Right? Do we take it or not? Right? We could just ask her, do we take the last object in our subsequence? And then she can answer yes or no. Right? And remember what I put on the steps at the beginning of the class, and I had one line that said, hint, try to have as few edges as possible, right? The number of edges corresponds to the degree of the right? And here I have two bird answers instead of n-bird answers, right? That goes back to short edges instead of long edges. She's really good. She's writing this down because you know you're going to need this for the test, right? All right. Suppose the solution is a tree, in which case we can ask the bird. We can ask the bird something about the root, and then we have a friend tells us the left subtree, and a friend tells the right subtree. Right? Does that make sense? So this is different, right? This doesn't reduce to shortest. All those others reduce to shortest path, right? This one doesn't. Why? Because we have two friends. Right? Does that make sense? We could ask about a leaf, but it doesn't seem to be that useful of a question, right? All right. Oh, maybe it'll come up in slides later, right? So now what's the set of sub-instances, right? Here, this, right? We have many friends that are asking the same question, right? What is the shortest path from here to here, right? So we just allocate one friend to that, right? And his job is to find the shortest path from V7 to T, right? And then when this guy is trying to solve his problem, he's going to ask him, and he's going to already have the solution, right? He's going to get it for you, and he's going to ask. All these people are going to ask the same guy, right? And in order to avoid waiting, right? He doesn't want to wait. In recursion, he would wait, right? He's going to go first before his other guys, right? Does that make sense? And he's going to store it in the table, right? So what is the set of sub-instances that need to be solved, in what order, right? Here's the entire instance, right? We need to, that's how to get from S to T, right? So if we ran the whole algorithm on it, determining the entire set of sub-instances, are we ever going to get to the sub-instance, the shortest path from V7 to T, right? Well, here, if she tells us, I guess at this point, she's telling us the last edge, the first edge, right? So sorry, this is before I turn things around, right? If she tells us our first edge, then our friend tells us the rest, right? So some friend will be dealing with this, right? But what about this sub-instance? Will it ever come up? No, because this node just wasn't part of our graph, right? I just stuck that in. It's never going to come up, right? And right, what about this sub-instance? Here's a tricky one. Are we ever going to need a shortest path from V3 to V7? Yeah, we're not. Why? Because all our paths, right, end in T, or if you go the other direction, they always end in S or begin in S, right? Right, so these are our subinstances, right? And so here, how do you find the set of subinstances? I tend to, we have this new way of coming up with subinstances, right? You're going through the game of life and you ask what does Pooh Bear need to remember, right? And so there's a state for everything he's remembering, right? So that's, I come up with the subinstances by what does the information Pooh needs to remember. But this is a different way of coming up with subinstances. I have my bird friend algorithm, and then I guess what the set of subinstances is. And what do I need my set of subinstances to have the property? They need to include the original instance, right? Like I like to say, if I'm getting married, you have to invite the bride and groom, right? And then it needs to be closed under the friend operation. What does that mean? That means closed under, if X and Y are both integers, then X plus Y is an integer, right? So we say integers are closed under addition, right? But here we're saying, if this is a subinstance that you're gonna need, some friend's gonna need to solve, then all his friends need to be in the set as well, right? Does that make sense? And you also need that each friend is likely to be needed by some, right? You don't want too many extra subinstances in there, right? And so those are our subinstances. What order do they go in? They go in from smallest to largest. All right, everybody got that? This says we need an optimal sub. Let's skip all of this. Oh, here